Alright, let's look at some integration of trigonometrical function. So when you deal with integration with a trigonometrical function, you have to check some of the powers that they contain in order to integrate. But integral like this, uh, you have to check the even powers. When you have the even power, you have different rules. When you have the odd power, use the other different rules. So to simple to simplify some of this, you have to know some of the rules to apply. So if you find an integral such as it's an even number, this is an even number, this is an even number, or like even power, even power. So even power, it's a number, it's a number that is divisible by 2 only, without the remainder. So you can divide 2 by 2 without the remainder, 4 by 2 without the remainder, 6 by 2 without the remainder. So if you find a function that have no as a 2, or as a number that is divisible by 2 without it's an even power, so you're able to apply some of the rules. So an odd power, it's number that is indivisible by 2. When I say indivisible by 2, I mean it cannot be divisible. You cannot divide it by 2. If you divide by 2, you will find that there is a remainder. So a remainder, if you divide 3 by 2, you'll find that there is a remainder. 5 by 2 is a remainder. So when you come across integration of this kind of function, we will use different kind of rules. So let's check the even power first. So if you find the even power, like the one that is above, the one that's a cos square, you'll have to use this rule. Because it's cos, you'll use this. And then from here you can integrate. Can able to integrate at this. When you find something like this, you change it to be when you find a trig, you have to change it to this, and then you integrate it, you simplify it. So the other one, this one as well, this one is like double of the integral. Then when it's like this, you have to expand it. You expand it, and then from then you will replace by this. You multiply, you replace it, and then you multiply all of them. Like you will add like this. And then you will multiply them all together. multiply this one by that one, this one by that one, this one by this one, this one by this one. Then at the end you'll integrate it. So same apply to this one. You have to expand it and multiply them all together, and then you integrate. So here you will find that you will reach at the point where you will find that you still find that is, let me see, we expand it. So this, you will reach at something like this when you multiply it. So from at this point you'll take the 4 out, and then you change you take the 1/4 out, and then you, and then here there's 2, you see there's 2, this 2 will multiply it again, you'll have 4. So it will continue like that. The more, when you get the square here, that means you will keep on multiplying this one by 2. It will be 8, like that, 16, and then continue, goes on. The more you expand it, the more you have the power. The more this thing goes up, this power change. You will have changes here when you expand it. You will see when you continue expanding this direction, you'll find it. So let's look at some odd. So for odd, you split it. Odd is a number that is like this: 3, 5 is divisible by 1 without the remainder. So let's say, let's check something. So let's check at this. So like this one, you always expand when you come across this one before you integrate. It's simplifying it, it's simple. And then you're simplifying this one. So now you have something like this. Then here you have to use the trigonometrical rule, the trigonometrical identity. So the trigonometrical identity, you can check here like this one and convert it to sine. So from this point, it's up to you whether you use the U substitution or you multiply them inside and then integrate one by one. So let me show the other one. The U substitution I will use at the exercises. This one is not a square. So you split one outside, and then but it will be difficult when you have a square. When you will use this method, it will be better use the U substitution when there is a, I'll show the next one. But if it's 3, it's simple. So you multiply by cos inside, multiply by cos 1, you'll find this, multiply this one by cos. So now you'll see the integral of this is simple. You can separate this one. So you'll have something like this, then you integrate from this point. So the cos now, it's like the derivative come from this so let's check this one. The one that 5. So this one 5, and then this one you first of all you split. And then when you split here, there's 4, and then you have to change simplify it like this. You can expand it if you want to expand it. But change the identity inside. So what you're trying to do, you are trying to change the identity to be the simplest form, like the one that you know, that cos square is this. So if you leave it by 4 here, you won't able to make this identity, like substitute by this identity here. So you're always trying to make it simple as for the identity that you know, so that it will be simplified. And then from here you will use the u substitution. You let sine to be u, and then you use the u substitution. Let's check this one. So looking at this one 7, yeah, I'm doing it because it's like this. It will show how you have to simplify. So this one you split, you only split one side when it's an odd. You split one, not 2 or 3, one, and like doing this. You don't do this. You only split one. Like one have to be must have a power of 1, and the other one have to be a bigger. So this one you always have to put it like in a power of 1 here. So this one you can leave it to the 6 or to this 6 or to the. So here you change it to the simplest identity that you know. Because we know cos square is we have, you know, the identity, you can use this one. So this 6 is a multiple of it's 3 times 2 is 6. So when you are here, you can able to insert so from here you can use the u substitution. Then from the u substitution, and then you can integrate, and then you replace the u after integrations. Okay, Now let's check some exercises after this one. So this one, it's even power starting from 3 cause not from 1, because the one with 1 we know how to integrate. This one, it's known, it's simple to find. This one, it's on the table, you check the table. So we can start from 3, 5, 7, 9, like that. These are the odd powers. So let's check at some exercises. One exercises. So solving this one using the rule of odd, because 5 is an odd number. So we'll break 5 and it will be 4 and 1. So from the first step, it will be like this. And then from this point you can change this one. And then from here, you know sine square according to identity, so you simplify it to the identity that you know. The identity that you know, it's the one that it's this one and this one, to simplify the sign. So we can replace sine square by 1 minus cos square. So you'll have something like 1 minus so from this point you can use a U substitution to simplify it. So using a U substitution, so you see there's a here. So from here you let U substitution. So after letting u to cos ax, you will derive the u, say du. Now when you derive this one, it's what? A, the derivation of the inner function. This one is a function of the angle. Then the derivative of cos is sine. It's negative sine. So from this point, we have to replace everything in terms of u, but because there is no a here, there is no a, you have to divide both sides by negative a. So this a will cancel this a. So from here you can replace everything in terms of u. You have to write everything in terms of u from this point. So you know that this one it's u, and this one you can replace by du, because it's you replace by this, because this one is the same as this one, and then this one you have let already to be u, you are replaced by u, and then replacing it everything else, you have something. So this one it's the same as this one. So where there is a sine ax, the x will replace by this, and then where there is cos you will replace by u here. This one was replaced by u, this one was replaced by negative du over a. So taking this a in front, because it's just a constant, you can deal with it. So you'll have something like negative 1 over a, like this. And then from this point there's a square here, you can expand this one. Expanding, you'll use your way to expand. So when you expand, say 1 square, it's 1. So the middle part you'll say multiply everything, as I'll demonstrate. 1 multiplied by u multiplied by 2. So you'll have something like 1 multiplied by u square multiplied by, or you can say even negative u, negative u, and 2, you'll have something like negative 2u square. So this is how you multiply the power, or expand in a simple way. So the answer So you square this all of this, the last part, because the first part you have squared this. In the second part you multiply this 1 multiplied by negative, you multiply by 2, and then the last part you square all of this with the negative, so we have positive because they squared, and then raised to 4 du. And then from here, don't worry about the constant. Then integrating this, we have u 3 plus but you, what did you say, what did we said about you? So you replace u by this one, and then we'll be done. So this is how you simplify, you integrate and simplify. So what you do here, you have to check the power first before you deal with the integral. Check the power here. If it's an odd, you have to break one part, then we'll leave with the highest part one side and the other one to the other side, like this. We'll be left with 4 this side, and then this one without the power here, the outside, and then you change this one to be there, and the identity that you know sine square is an identity, so you can simplify it, and then you replace by the identity, the sine square, and then from here, see as a square. So from here you change it to be u, then from there you substitute the u, expand it, then after expanding integrate it, and then you replace the u. This is how you integrate a trigonometrical function with the other power. in even power, so you just expand everything with even power. You don't break, you expand everything.